We are now go over entity practice exam thermochemistry. We are now go over entity practice exam thermochemistry set of question. It's on page 4 of the practice exam reader, question 7. The question has been projected, so I'm not going to copy the question on the board, but I will still go over it on the board. Oh, yes. Okay. So let's see what does the question say. It says blah 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 blah, but the key word is this is a bomb calorimeter. Not sure if you still record, but I have my lecture notes too. So I did draw 2 different kind of calorimeter. One of them have specific volume, which is this one. Okay, so we said whenever you want to do a bulk calorimeter, you don't want to hurt others, so you want them to be in a sealed container. Means your delta V change of volume is 0 whenever you do the bump. Let's say the bump. Okay, it's still in this sealed system. However, when it's bumped, it might release more gas, whatever. So the delta P, the change of pressure, it can be different. The different one is the coffee cup calorimeter, which is the one you guys are doing in lab, right? That one, delta V will not be 0, but delta P will be 0. Okay, that's the difference between the one that we are having. Okay, just make sure we're on the same page with this one. Okay, what else is here? So apart from delta V, which is the change of the volume, there are also sigma Q is 0, which is the total amount of heat. Okay, what are we referring to? Okay, if you just make sure you're also on the same page. You should also have delta Q equals to 0, somewhere, right? Okay. What does the delta Q means? Means this whole system, no matter is the heat released by the reaction. Okay, this reaction is bump. Okay, it's going to give out heat to this calorimeter. This calorimeter has 2 different stuff inside. One is the calorimeter itself. That's what I refer to in my class. You remember I was circle this sealed container. We say sometimes there will be, we'll say this container can take some heat because sometimes we ignore it. Most time we ignore it, but sometimes we do. Okay, and we said this bomb calorimeter is everything happens in water, right? Yes, right? Okay, what does this water do? When you have this bomb explode, not sure if the people in the video can see, there's a Q water, okay? When you bomb, the water here is going to increase a certain temperature, right? And this calorimeter cell is also going to take some heat because you seal them. So when the reaction happens, there are 2. Okay, when the reaction happens, Q reaction. When the reaction happens, it's being transferred into 2 different places. One is the sealed container itself, the other is the water. So pretty much this is Q reaction, transfer into that, transfer into this. Are we cool with this? Okay, total amount of heat is 0, Q reaction, Q calorimeter, Q water, which is this light blue. Not sure if the video can see this, but this is the total Q, which I was referring to. Okay, what do we ask? Q reaction, which means if you want to move reaction to move both to the other side. Okay, Q reaction equals to minus this 2 together. We shift this Q to the other side. Will be Q calorimeter and Q water. If you want to calculate specifically, let's make this into a long question. But for multiple choice, C is that. But since we're here, we want to make it into a long question. We can, based on what has been provided, we can calculate the Q. Do people want it? Okay, that will be the second video. But so far, this one is choice C because of this. But we will continue from here. Are we cool? Yeah.